Welcome to the lesson on comparing and ordering numbers. In mathematics, we use several symbols to compare numbers. There's the greater than symbol, there is the less than symbol, and there is the equal to symbol. For example, -2 is greater than -4. 3 1/5 is less than 8. And 90% is equal to 0.90. Don't forget, in our previous lesson, 90%, here's the decimal, move it 2 places to the left, and that changes the percent into a decimal, moving it 2 places to the left, because percent means out of 100. And so we're going to move it 2 places to the left, dividing 90 by 100, or putting this 0 in the hundredths place. Use the number line to compare rational numbers. So one way is to plot the points on the number line. The numbers farther to the right are larger, so here are our larger numbers. And to the left, they're smaller. So on this particular number line, -10 is shown here as the smallest number that is marked. Of course, this arrow means it keeps going forever to the left. The largest number that you can see labeled is 10, but remember the arrow means it's going on forever. So to get to larger numbers on a number line, the farther right you go, the larger the number. The farther left we go, the smaller the number. Integers are marked on the number line, but all rational numbers are on the number line, many located between the numbers. -3 1/4 is between -3 and -4. 5.34 is between 5 and 6. 20% is actually 0.20, again, decimal at the end, 2 places to the left, changes the percent to the decimal, and it's located between 0 and 1. To compare rational numbers, put the numbers you are comparing in decimal form. Here's how you change fractions to decimal form. 3/4 is a fraction, and the fraction bar means divide. So in a calculator, take 3 and divide it by 4. This gives you 0.75. 2 1/4 is a mixed number. It has a whole part and a fraction part. That's what mixed number means. So this means 2 plus 1/4. So in a calculator, you would put 2 plus 1 divided by 4 to change it to a decimal. And that's 2.25, 2.25, 2 25 hundredths. So remember, to compare decimals, or to compare rational numbers, we're going to put them in decimal form. Here's an example of how we're going to compare. We either need to put a greater than, less than, or equal to in our box. You may already know that 3.45 is greater than 2.49, but 3.45 is located here between 2 and 4. It's located here between 3 and 4, 3.45. 2.49 is located between 2 and 3. So the yellow, the 2.49, is to the left of the 3.45. 3.5 is more to the right, so the farther to the right you are, the greater you are. So the farther number to the right is the greater number. Here's another one, but we have a percent. In order to compare, we want both numbers in decimal form. So 28% from our previous lesson This is the decimal, and to understand a percent, it's out of 100. Dividing by 100 moves a decimal 2 places to the left, 0.28. So we want to think of this number as 0.28. And now we're going to compare those. Well, they are both located between 0 and 1. But 0.28 is going to become before the 0.30. So 0.30 is the greater number. Also, you might think of this in money terms. Since it is has a hundredths place, this is more like 30 cent and 28 cent. So 30 cent is larger than 28 cent. That's another way to think about it. Here's another example, -7 1/4 and -8. But again, we're going to take this and change it to a decimal form. So we're going to use a calculator, and we're going to say, we're just going to put in the 7. We're going to forget the negative right now. We're just going to change it to a decimal. Do not put the negative in the calculator. Let's just change 7 1/4 to a decimal. So 7 plus 1 divided by 4. If you include the negative, it will throw your answer off, because that is not how you change a mixed number into a decimal. You just take the mixed number, don't think about the sign, do that first. 7 plus 1 divided by 4 is 7.25. So then it's -7.25 as the decimal form. Well, -7.25 is between -7 and -8. So it's maybe right here. -8 is right on the -8. This is to the right of the -8. So -7 1/4 is actually greater than -8. In this example, you're going to see how to take a group of numbers and put them in order. So here are our numbers in this chart. I'm going to change a few of them to make them decimal form. Let me erase my box. We've got 3 1/4. And a calculator would be 3 plus 1 divided by 4. That gives us 3.25. So that's what that one is. 12% here. We've got to work on that one. To the 12%. Decimal here. Previous lesson, percent's out of 100. Dividing by 100 moves the decimal 2 places to the left, or 0.12 is the decimal form of 12%. And then we have another one that looks kind of strange. It's 3 with a little 2. Well, that's 3 to the second power, or 3 times 3. You also can put that in the calculator, but 3 squared, right here, 3 squared is 3 to the second power. It means 3 times 3, and that is 9. So I have now changed everything so that they're all in a decimal form and not some other form. Like here, this is in exponent form. We don't want that. We just want it in decimal form. Whole numbers are in decimal form. So I'm going to go through here, and I am going to label these numbers. 3.25 would be right here, between here. Then we have the number 2. It's right there. Negative 1.5 is here. 12% is between 0 and 1. 9 is here. And 7 is here. And if I color coded these, you might be able to better see it. So this number here was the negative 1.5. So it is our smallest number because we put it on the number line and saw that. This number here was the one that was between 0 and 1. That was the 0.12. This is on 2. The number between 3 and 4 from our list is 3.25. Then we have a solid whole number of 7, and then 9. So now I have put them in order. So you'll be doing some of those in your assignment to take a list, put them first in decimal form, plot them if you would like, so that you can see what order they go in. So the number between -1 and -2 was smallest. Between 0 and 1 came next. Then the whole number 2. Then the number between 3 and 4. Whole number 7 and a whole number 9. Now I've put these rational numbers in order.